Alright class, so this lesson we're going to talk about functions and how functions are used in Algebra 2. You might have heard about functions from your previous math classes, so this might be a review for you, but I'm going to highlight what we need as far as functions for Algebra 2. Okay, and I'm mainly going to talk about special notations that we use that are important for this course. Okay, so looking at this first sentence here, it says relationship between numbers exists in all mathematics and in real life. So when we're talking about relationships, we're talking about how two or more things interact with each other. Okay, so in math and for functions, we're talking about a function is a special relation where each x value is paired with exactly one y value. Okay, we call this an ordered pair, and we write it like this. And just look at how it's written. You write your parentheses, then you always write your x coordinate first with a comma, and then you write your y coordinate. So this is when you see something like this, we're looking at an x and y coordinate and how they're paired with each other. So and for Algebra 2, something that might be new is when we're talking about function notation, how do we denote that it's a function that we're talking about? Okay, function notation is a way for functions to have special notations. A relation is a function if you see f of x or g of x. So I just said that a little too fast. Let me slow down. F parentheses x close parentheses. This is whole thing right here means we're talking about a function, okay? Or we can say g of x, we're talking about a function. So you have an x coordinate and you have a y coordinate, okay? You can use any letter of the alphabet. So it doesn't have to say F, doesn't have to say G. You can use other letters, but common one you'll see would be F of x or G of x, but you're not just restricted to that, okay? The y, when we're talking about the y, we're talking about the y coordinate here. The y has been replaced with f of x, okay? So sometimes you might see this. You have a coordinate, so you have x coordinate, and you have your y coordinate up here. But sometimes what happens is you might see this you have your x coordinate, and then you will write f of x right here. This just represents your y coordinate, because we're gonna go through some examples about how it works. It says that it means that the value of the function f at x. So whenever you plug in, that term, when you plug in something or you input, you get an output. When I plug in, for example, over here, if I say x is if I plug in 2 here, that means that I plug in 2 here, so 2 squared will be 4. So how would I write that as an ordered pair? My x that I plugged in here was 2, and what is my f of x or my y? Is 4. Okay, that's how I get my ordered pair. I'm just gonna leave this here, take that out. I just wanted to, and we're gonna go through a lot more examples with that. Okay, all right. So let's look at examples of new notation. So this might look familiar to you if you're coming right from Algebra 2. Algebra 1. So an old notation might look like this. You have y equals 4x plus 2. And the new notation, we would just simply change the y to f of x equals 4x plus 2. We're going to look at a graph of it, but before I do that, let's get some ordered pair for this function. So for f of x equals 4x plus 2, for this function, I'm going to look at some ordered pairs. So let's just pick some x coordinates. Let's pick 1. I'm going to plug in 1 here. So if I plug in 1 here, so it's going to be 4 times 1 plus 2. So 4 times 1 is 4 plus 2 is 6. Your output or your y coordinate will be 6. I'm going to put that on here. So when I plug in 1, I get 6. So I'm going to plot that point here. Oh, it went a little above the chart, but it's right there. Okay, let me look at another coordinate. Let me look at what is this function doing at 0. Okay, so which means that you have, I'll do the work for you so you see. So I'm going to do 4 instead of x, I'm going to plug in 0 plus 2. So 4 times 0 is 0, not 4. 0 plus 2 is 2. So when I plug in 0 for x, my output is 2. So that's my ordered pair. Let me look at it on the graph. So you have 0. My y-coordinate is 2 right there. Okay, let me just do one more. Let's do a negative number. Let's look at 1. Negative 1. If I plug in negative 1, so I'm going to go here, I'm going to do 4. My x becomes negative 1 plus 2. So 4 times negative 1 is negative 4 plus 2. Negative 4 plus 2 is negative 2. So my output here is negative 2. And then let me graph it. Negative 1. My y is negative 2. There you go. Oh, it's a line. And then I'm going to connect the dots to finish graphing it. Let me see if I can do a nice line. No way. That is not good. Let me just use a tool here. Okay, let me just connect these dots. There you go. That's my graph here. I'm gonna put an arrow here and an arrow here representing that this line does go on forever. I can put as many x coordinates going off to infinity. I can put n as many x coordinates here, and then this line would extend out. Okay? But the main thing here, I want you to know that over here your y is f of x. And when we do this, we can know what to input, and we know the result is going to be your output. Okay? Another notation you might see is you have y1, y2. We're talking about two different functions. So when we're talking about two different functions in one problem, we're going to say, okay, well, f of x is equal to 4x plus 2. And then for y2, I'm going to just, I can use any other alphabet. So I'm going to put g of x equals negative 3x plus 7. Okay? And then when I graph it, I'm going to graph two different functions. I'm going to have two different graphs. Okay? So I'm not going to redo all these coordinates. We have this point, and the other one, the same one, because it's 4x plus 2. It's the same exact function. So I'm just going to copy it. Oh, that wasn't too bad. And then my g of x, I will have to do it. So for g of x, let me get some coordinates going here. And, all right, I'm gonna probably go ahead and introduce the calculator piece here, okay? So now let's just make use of our wonderful calculators, and let's see if we can get some coordinates using our calculator. So we're gonna go to our calculator. I don't have it open. Okay, so I have my calculator up. I am going to find my coordinates using my calculator. So I'm going to go to y equals. So now you know y equals is the same thing as f of x equals right here. Okay, I'm going to go to y equals, and I'm going to plug in. You don't have to, but if you want to check it, I'm just going to plug this in. You have 4, and this x right here is always going to be this button right here, this big x over here. Just always use that x plus 2. So that's y1. And then I'm going to jump down here and plug in my next function. G of x is y2. That's how I have it written here as well. Okay. So I hope you're seeing how it's not like I'm teaching you a new skill here. You probably know how to do this from your previous math classes, but I'm just showing you how is it that we communicate functions, okay, using function notations. Negative 3x plus 7, and then I have both of them, and then I'm going to hit graph. Oh, there's my first one, f of x, and then my next one is going down, so it's going between here. I'm just going to kind of guess here. There we go, and then there's the other one, okay? Yeah, There we go. All right, the last example here. You have y equals square root of x. So if you want to write it in function notation, we're going to say f of x equals, do you always have to use f of x? No, but that's just, you're going to see mostly f of x. That's why I'm using that. F of x equals square root of x. I'm going to use my calculator to graph this. So go to y equals. We're going to hit clear. I'm going to clear this out. And I'm going to, in y1, or I'm going to plug in f of x. So you have square root of x. We're going to graph it. There's the graph. Something like that. All right. How do I get coordinates? How do I look at what my x and y values are? You're going to go to your table to do that. Okay? So go to second table, and here you go. Here's your x coordinates and y coordinates. And if you hit the up arrow, you can see your negative numbers. And if you go down, you can go higher on the number line. So I'm just going to write a few coordinates down. So I see here 0 goes to 0. I'm not going to write down error. Why does it say error? Because there's nothing here graphed. And we'll talk more about that later. But let me just write some coordinates. 4 goes to 2. And go down. Let's see, I'll pick a nice clean one. 9 goes to 3. I mean, I could write the decimals, but I'm just going to pick these ones. Okay? All right, so the main thing here I want you to get is how to write functions and function notation and how we use them. All right, so here's some examples on determining if a given relationship is a function or not, okay? So it says here, is a relation a function? So when we look at this, we're going to look at the graph, and I wanted to talk to you about the vertical line test. So a function, what's unique to a function is, when you have an x value on the number line, x here, it always has one y value, okay? It's not, this one is not going to have another y value somewhere down here. Like, for example, I have a graph that looks like this. And I'm going to erase it, so don't write this down in your notes. Let's say you have a graph that looks like that, okay? You see how this x value is hitting it over here and over here. We cannot have that. Okay, we cannot have a one x value going to more than one thing on your y value. Okay, if you have that, then it is not a function. That's not the kind of relationship this relation should have. So I'm going to do a vertical line test. All that means is I'm going to draw vertical lines throughout my graph. They don't have to be perfect, but you notice how the graph is hitting the vertical lines are hitting the graph at only one place. So since it's only going to one y coordinate, we can say yes, it's a function. This relation, yes, it is a function. Yes, it is a function. Okay. The second example. If we do the vertical line test, I'm just going to draw some vertical lines. Already failed right here. It's hitting it at two different places. So this is no. It's not a function because it fails the vertical line test. Okay? How do we determine if it's a function? If we just have these coordinates, okay? So we're just going to check to make sure that none of the x's are repeating, okay? So -4 is going to -4. -2 is going to -1. You can plot these and do the vertical line test as well. 0 is going to 2, and 2 is going to 5. Okay, I don't have anything repeating here. Nothing is repeating here. So let me just circle it. This is how I like to check it. But let me circle this. And then here I noticed that there are no x repeating. There are no x coordinates repeating. You can have y coordinates repeating, that's fine, but if you have any x coordinates repeating here, then if you don't, since there's no repeating x coordinates, we can say yes, a function let's look at this one. I have -5 going to 3. Sorry, screen. -5 is going to 3. And then I have this coordinate here. It says that you have -5 going to 4. Already fills. I have something repeating here. Okay? I have an x coordinate repeating, so nope, I can say no, not a function. Okay? Last one. I have a graph, so I'm going to go ahead and do some vertical line tests. It only hits it once. I'm good here. I'm good here. What about here? What about this one right here? There's a closed circle, something that's filled, which means the function has a value there, but we have an open circle here. So technically this is not hitting it at 2 places because you can say there's a hole right there. So there's no value over there, over here, okay? So this is, we're still good here. It's still good for the vertical line test, and same thing here. So so we can say yes. Oh, sorry about that. We can say yes if it is a function because it passes the vertical line. It is a function because it passes the vertical line test. Okay. On this page, this is your practice page. Please complete these questions and let me know if you have any questions. Okay, we have up until problem 7.